Hi everyone, this is Mrs. G.A. and today we're going to talk about simple and compound interest. So I have a quick warm-up for you guys that has to do with what we learned in the previous lesson, so please pause the video and give it a try. Alright, so this is the compound interest formula that we learned in the last lesson. A equals P times 1 plus R over N to the NT. Here's what all of the different variables represent. So we will be reviewing this again in this lesson, as well as learning the simple interest formula. So the simple interest formula is a formula that you can use to find out how much interest you earned over an amount of time. So the formula is I equals P times R times T. So P is that principal or initial amount. R is the interest rate as a decimal, as it always is. T is time in years, and this time I, again, is the amount of interest you earn. So we learned other formulas for a simple interest investment, but that formula told us how much our total, the total account was worth after a given amount of time. So this formula tells you just how much interest you have accrued. So it's just for the simple interest. So let's try a couple of these together. This one says you invest $450 at 3% for 5 years. How much interest did you earn? So this one, pretty straightforward. I equals P times R times T. So we see here that P is 450. That's how much we initially invested. R equals 0.03, which is 3% as a decimal. And T equals 5 for 5 years. And this should tell us how much interest we've earned. So 450 times 0.03 times 5. So here we should get I equals 67.5, which would be $67.50. So again, this is a formula to calculate how much interest you've earned. If you wanted to see how much is your account worth total after the 5 years, you would take your initial and you'd add the interest that you've earned. Okay, let's try another one together. So this is you invested $12,000 for 8 years in an account that earned a total of $95 in interest. What was the interest rate? So we're still going to use that same formula, I equals P times R times T, but now we're solving for something different. They're asking us what is the interest rate. So this time we're solving for R. So let's see what information we know. We know that our principal was $1,200, because that's how much we started with. We can see that T is 8. That's how many years the account sat there, and it earned $95 in interest. So that's I. And then we can use these, substitute them in, and we can solve for R. So 95 equals 12,000 times R times 8. So now we're just solving, so we can multiply 12,000 and 8 to get 9,600 R, and then we can divide both sides by 9,600, and we end up with R equals 0.009, and I'll round it off there, 0.0099. So if we want the interest rate, we usually do that as a percentage, so we're going to do the opposite of what we usually do, and we're going to move our decimal point 2 spaces to the right. So it's 0.99% interest rate, so just under 1% interest. So a pretty low interest rate, which is why we didn't have that much interest accrued over those 8 years. But again, remember the R value that we get from our formula is going to be as a decimal. We do need to convert it to a percentage. All right, let's try another one. This one says you invested money into an account that yields 2% interest, and you had it in there for 35 years. Over the course of that time, you earned $2,000 in interest. How much did you initially invest in the account? So you can see that we can use that same formula because it involves the amount of interest you earned, but this time we're trying to find the principal. How much did you initially invest? So the other information we have, well, it says that the account yields 2% interest. So we know that our R value is 0.02. Says that we had it in there for 35 years, so that's T. And over that time, we earned $2,000 in interest. So that's our I value. So let's substitute what we know. 2,000 equals P, which is what we're solving for, times 0.02 times 35. And now we just need to solve for P. So we can start by doing 0.02 times 35. So we get 2,000 equals 0.7 P. And then we can divide both sides by 0.7. And we should get P equals 2,857.14. So we'll write our final answer as in terms of dollars, so $2,857.14. All right, so let's try one more of these simple interest problems together. This one says, how long would it take? So you can see right off the bat that this time we're solving for T. An account that pays 9% interest to earn $500 if you initially invest $8,000. So again, this one we can use that interest formula. And we are solving for T this time. This is how long would it take. So the information we're given, we know that the interest rate was 9%, so R equals 0.09. It says to earn $500, so that was the interest we earned. So that's I. And you initially invested $8,000, so that's P, our principal. So let's plug in what we know. So 500 equals 8,000 times 0.09 times T. So now we just need to solve for T. So you can start by doing 8,000 times 0.09, so we get 500 equals 720 T. And then you can divide both sides by 720. And here, I'll just round to the nearest tenth. We would get 0.7. So it only takes 0.7 years, so less than a year, for your $8,000 to earn $500 at 9% interest. All right, so now we're going to move on to that compound interest formula. We did learn about this in the last lesson, but we're going to review it again. So again, it's A equals P times 1 plus R over N to the power of NT. So P is, again, the principal amount, R is the interest rate as a decimal, N is the number of times per year it's compounded, and T is the amount in years, and it will tell us the final amount that our account is worth, which is A. So in this example, we're going to look at a scenario, and we're going to see how much our account is worth if it's compounded differently. So if it's compounded annually, semi-annually, etc. So we'll see how changing the number of times per year an account is compounded will affect how much money we earn. So to start, it says you invest $15,000 in an account that yields 3% interest. So that we know is P is 15,000, our principal, and R is 0.03, 3% as a decimal. How much will the account be worth after 10 years if, so T equals 10, it is compounded annually? So annually would be once per year. So essentially, it's a simple interest investment, but let's use our formula. So A equals P, 15,000, times 1 plus 0.03 over 1 to the power of 1, which is our n, times t, which is 10. So again, compounded annually means once per year. And then let's plug this into our calculator and see what we get. So given this scenario, we would get approximately $20,158.75. All right, so let's see how that changes if we compound semi-annually, meaning twice per year. So everything's going to be the same except for n. So we still have 1,500 or 15,000 plus or times 1 plus r over n. This time n is 2 to the power of 2 times 10. So let's plug this into our calculator real quick. And here you should get $20,202.83. So you can see that simply by compounding it one more time per year, we earned more money. So if you compare the first one to the second one, you can see, oh, there is a little bit of an improvement there. So let's do one more together. Let's try compounding quarterly and see how much that would earn us. So quarterly means 4 times a year. So A equals 15,000 times 1 plus 0.03 divided by 4 to the power of 4 times 10, so to the power of 40. Plug this into your calculator, and please don't skip the step where you're plugging it into your calculator because I do see a lot of calculator input errors with these problems. So if you're not practicing it, you won't know if you're typing it in wrong. So please make sure you're typing it in exactly how you see it so your calculator will follow order of operations. So here, for this one, you should get $20,225.23. So you can see that we get even more money. So the more times you compound, the better your payoff. So I'd like you guys to pause the video, and I want you guys to give these last two a try. So compounded monthly means that n is 12 times a year, and compounded daily means that n would be 365 days per year. So pause the video, and when you're ready to check, go ahead and hit play. All right, go ahead and check your work here. So for compounded monthly, you can see the big change was that n is 12. So here and here. And it does yield a little bit more money, so $20,240.30. And then for compounded daily, 365 is your end value, and again, you get a little bit more money than you did when it's compounded monthly. But you can see the general trend that the more often your account is compounded, the more money you will earn over time. All right, so that is all for today's video. Thank you so much for watching.